Hello everyone, happy to see you here on my channel Hi Mathematics, and today we have really interesting question: x to the power squared of x equal to 3, and we need to find our x. Right now you can easily pause the video and write your assumption, write your solution down into the comment section. It will be really interesting to check our answers in a few minutes, so it's really great question for everyone. So here's our question: x to the power squared of x equal to 3. So how can we solve this question? Just look at my approach. First of all, instead of this x, let's write, so just take a look closely. We have x, and instead of this x we're going to write square root of x square. Okay, this is absolutely the same thing. If we raise this square root of x to the second power, we have our x. So instead of this x right here, let's write this square root of x to the second power. So let's do this right now. So as a result, what do we have right here? Square root of x. We have right here, we raise this to the second power, and we raise all of the thing by square root of x. We have this square root of x right here. Okay, square root of x equal to 3. Really great. Right now we need to remember, we need to learn a really interesting, really important school property. If we have a to the power b raised to the power c, it is equal to a to the power b times c. This is very basic school property, and we're going to multiply 2 times square root of x. So as a result, what do we have right here? We have square root of x to the power 2 square root of x. Yeah, we're going to multiply this 2 times square root of x, and this is equal to 3. So really great. Right now, let's look closely what do we have right here. Of course, right here we can easily take it inside parentheses because this looks like complicated expression, but it changed nothing. We're going to write a substitution because we have square root of x right here and square root of x right here. So let this square root of x is equal to, for example, let's go with y. Okay, square root of x equal to y. And as a result, after this substitution, we have our question. Our question looks like that. We have y to the power 2y. Okay, we have y to the power 2y equal to 3. Okay, this is our question right now without any square roots right here. So this is really great. Right now, let's solve this challenge, and after finding our y, we're gonna go back to this substitution. Okay, so really great. Right now, let's look closely what do we have right here. We have a power, and if you know a little bit about natural log or about log, basically, we can easily apply this natural log on both sides, and as a result, this 2y will come down right here. So let's do this right now. So let's apply natural log on both sides. We have right here natural log of y to the power 2y, and on the right side we have natural log of 3. Really great. Right now, as I told before, this 2y will come down right here, and as a result, what do we have? We have 2y times natural log y equal to natural log 3. So this is our expression right now. Right now, let's try to group our variables on the left side and our constant on the right side. To do this, we need to divide both sides by 2. Right here we have constant, so if we divide both sides by 2, it constant appears over here in our denominator. So let's divide both sides by these 2. When we divide both sides by 2, what do we have right here? We have a fraction on the left side. We have 2y times natural log y over 2 equal to natural log 3 over 2. As I told before, we're going to cancel this y, these 2 and these 2 right here. So as a result, our expression right now looks like that. We have y times natural log y, yeah, y times natural log y equal to natural log 3 over 2. Really great. Our variables on the left side and our constant on the right side. Right now, there are a lot of approaches how can do that, but the best one is to apply Lambert W function. But as you know, we need to have like e, and so we need to have like that. We need to have a times e to the power a. When we create expression like that, then we can easily apply Lambert W function, and as a result, we have our a as a result, yeah? But we need to create e at first. This is like a first step. It doesn't matter what expression do we have, we need to create e. And in our case, it's really easy to create this e because this y can be written as e to the power natural log y. So instead of this y, let's write e to the power natural log y, okay? And we still have this expression, so times natural log y equal to natural log 3 over 2. Really great. So instead of this y, we read this e to the power natural log y, which is absolutely the same, so it changed nothing, okay? And right now, if you look closely, before I wrote this Lambert W function explanation, we need to have like a, so a is wherever we want expression, we need to have e, and we need to have the same expression right here, so as a power and as expression right here behind this e. So we can easily change an order a little bit right here. We can easily do that because this is multiplication, so we can easily write natural log y times e to the power natural log y equal to natural log 3 over 2. And right now let's look closely what do we have right here. For example, this natural log y, this is our a. And we have the same expression right here. So this natural log y, this is also a. And we have our case a times e to the power a. So we can easily apply this Lambert W function. So this is like very easy expression for us to create Lambert W function because we have everything right now. We only need to write this y as e to the power natural log y. This is only one step. And this is our general case to apply Lambert W function. So let's do this. So Lambert W function of natural log y times e to the power natural log y equal to, and we need to apply this Lambert W function on the right side. So Lambert W function of this constant natural log 3 over 2. Right now, let's look closely. As I told before, this is a, and as a result, we will have our a. So on the left side, we have only natural log y. Okay, so we will have only natural log y equal to Lambert W function of this constant. Okay, Lambert W function natural log 3 over 2. Really great. What are we going to do next? We need to find our y. We don't need this natural log. We need to find our y, and then we go back to this substitution. We have this substitution right here. So right now let's do this. Let's find our y. How can we do this? We need to write base of e on both sides, and as a result we will cancel this natural log y with this e, and it appears this y right here. So on the left side we will cancel this natural log when we create base of e on both sides, and it appears right here on the right side. So our y is equal to e to the power Lambert W function of this expression, natural log 3 over 2. This looks like our answer, but we had a substitution in the beginning. So let's write but square root of x equal to y. So it's not our final answer. In the beginning, what we had in the beginning, we had x to the power square root of x equal to 3. This is our question in the beginning, so we need to find our x. Right here we have y, we need to find our x. So this looks like basic thing for us to write a substitution and to find our x from this y. Okay, so let's do this right now. So from this step we know that square root of x equal to y. So from here, if we raise both sides to the second power, so if we squared both sides to the second power, we have that our x equal to y square. And we know about our y, we know everything about it. So right now, instead of this y, let's write our expression right here. So as a result, what do we have right here? We have a parenthesis, and we raise this e to the power Lambert W function of natural log 3 over 2. We're gonna raise this to the second power. We need to do this right now. We're gonna raise this to the second power. And we had this property before. I'm going to write this property once more right here. If we have a to the power b raised to the power c, this is equal to a to the power b times c. So we're gonna multiply our powers. This is our power, this is our complicated power, but doesn't matter. This is a power Lambert W function of this constant. This is a power of e, and we raise this power to the second power. So as a result, we need to multiply 2 times this Lambert W function. Okay, according to this school property. Okay, according to this school property. So this is equal to. Let's write in a new line. So we have x equal to, as a result, e to the power 2 Lambert W function, of natural log 3 over 2. Natural log 3 over 2, and this looks like our answer. We know everything about e. This is a all-known constant. We know Lambert W. We don't know like in our head about these values of Lambert W function, but this is generally constant, so we can easily find our approximately answer to this question. We can easily do this, and I find this answer for you. Let's write a final answer right here. So our answer, okay, our answer, x equal to e to the power 2 Lambert W function of natural log 3 over 2, and I find approximately value for you, and maybe someone interested, x approximately equal to 2.13. You can easily solve this challenge. You can easily find this approximately answer in your internet libraries, but I find it for you. Right now I'm going to show a graph, so we can also see that there is only one point of intersection. So right now we are talking about only one point of intersection, only one solution, because x to the power square root of x, we have right here our function x to the power square root of x, and this line x equal to 3 have only one point of intersection. So we are talking only about one root, so we can easily see that we have only one real number. This is not like integer solution, but doesn't matter. We have real number root, and this is only one only one solution to this challenge. This is a really interesting question to practice your Lambert W function, to practice your substitution skills, to practice your school knowledge. Right here we have a lot of school properties, this property right here, this property in the beginning, yeah, and a really interesting question, I guess, for everyone to practice your school knowledge. So I hope your answer is the same as mine. You can also write your solution down into the comment section, write your assumption down into the comment section. It will be really interesting to read about it. It's really interesting to exchange information, because a lot of teachers, a lot of approaches, yeah, this is not only this approach, maybe you have your own approach. It is also really interesting to read about it, and it's really interesting to exchange information into the comment section. It is really great for everyone. So thank you for your time, thank you for your support. I hope this video is helpful in any way, but if this video is helpful, you can easily support me with a like and in the comment. I really appreciate it. It's really grateful from you to support this video. So thank you for your time, have a great day, see you in the next videos, and take care.